Before starting the lesson, try this warm-up. Write the area formula for each shape. So we have a rectangle, triangle, trapezoid, and circle. I have some things labeled on each of these. See if you can remember the formulas for area. If you can't remember, look them up. Pause the video, try it, and then come back to see how you do. For a rectangle, length times width. For a triangle, the base times the height divided by 2. Now just a note here, height and base are just perpendicular to each other. So if the side of your triangle is not perpendicular to the base, then it's not the height. If you have a right triangle, then the height is one of the sides of your triangle. For a trapezoid, A plus B, so add up the two parallel sides, multiply by the height, and then divide that by 2. And for a circle, area is pi times the radius squared. Remember, radius is half of the diameter. It's from the center to the outside, not all the way across. Okay, so keep these formulas in mind as we go through this lesson, because we're talking about surface area and volume for basic geometric shapes. Okay, so we're going to be focusing on three-dimensional objects, and we're going to determine the surface area and volume for a variety of those different geometric shapes. And you've talked about surface area and volume in previous math courses, I'm sure. However, let's start with some definitions just to make sure we remember. So surface area is the total area of all 2D surfaces on the object. So if I have a rectangular prism, there's 6 different surfaces made up of rectangles. So if I found the area of each rectangular face and added them together, that would be the total surface area. I think of that as an example would be wrapping paper. It goes on the outside of the box, the outside of the gift. It does not fill the inside. Whereas volume is the total amount of 3D space that fills the object. So this would be how much total space is inside the box, whereas surface area is how much wrapping paper goes on the outside. Okay, so that's just the distinction between surface area and volume in case you have forgotten. We'll start with a sphere. So this is an attempt at drawing a sphere. This is supposed to just show that there's depth to this drawing. Okay, so if you know the radius of the sphere, so the distance from the center inside the sphere to the outside, then you can figure out surface area and volume. Now, with all the other shapes that we're going to look at in this lesson, we're going to be breaking the large 3D object into its two-dimensional pieces. You can't really do that with a sphere, so I'm just going to show you the formulas for surface area and volume of a sphere. Surface area is 4 pi r squared. Volume is 4 pi r cubed divided by 3. All right, so copy those formulas down so that you know how to calculate surface area and volume of a sphere. And just a side note here, if you look up formulas on the internet, it might just say A equals. I like to use SA for surface area because then in my mind, I know that I'm still talking about a 3D object as opposed to a two-dimensional surface. Now let's move on to prisms. So a prism is really any 3D object that has 2 parallel faces that are the same shape and same size, and they're perpendicular to each other. So here's a rectangular prism. Really, any of the faces can be counted as the base. So any of these rectangles, because it's parallel to the same rectangle on the other side. With a triangular prism, though, the base is a triangle because it's the 2 triangles that are parallel to each other. Whereas in a cylinder, it's the circle that's the base because there's 2 circles that are parallel to each other. So whatever the parallel sides are, that's what we're going to call the base of the prism. To calculate the volume of a prism, you just need to know the area of that base multiplied by the height of the prism. So if this rectangular prism has a base with length and width, the area of that base is length times width, and then I multiply by the height. So length times width times height is the volume of a rectangular prism. For a triangular prism, well, here I have it labeled BL, okay? So base times length of the triangle divided by 2. So just using that area formula for the area of a triangle, and then multiplied by the height. The base is the circle, so pi r squared times the height in a cylinder. Okay, so area of base is the area of whatever shape is the base of your prism. Could be a rectangle, could be a triangle, could be a circle, could be something else. Whatever the area of your base is, multiply that by the height of the prism, and there you get the volume of the whole prism. So in this example, I have just a generic triangular prism. I've labeled some sides with letters. Okay, so we've got B, L, H, A, C. Those labels can help us develop a formula for surface area and volume of this triangular prism. Let's start with volume, since I just talked about how to find volume of a prism. First, we need to know the area of the base. Well, the base is the triangle. So what's the area of the triangle? Well, it's B times L divided by 2. Then I need to multiply that area of the base by the height of the prism. So I end up with BL over 2 times H, or I can simplify that to BLH over 2. So there you have the volume formula for a triangular prism. Now let's talk about surface area. So you have to imagine this prism in real life. You can cut it into its individual faces. Okay, so we have a triangular face on the top, the same size triangular face on the bottom. Then we have on the one side a rectangle, on the other side a rectangle, and then on the front here we have another rectangle. So we have 3 rectangles and 2 triangles. If we find the area of each of those faces, we can add them together to get the total surface area. So I have 2 triangles. Each triangle has an area of BL over 2. The one rectangular side is A times H. This side times this, length times width, A times H. CH is this rectangle, and BH is the area of this rectangle on the front. So I have 2 triangles, 1, 2, 3 rectangles. If I add them all together, I get the total surface area. Now this part here, I can simplify because multiply by 2, divide by 2, those cancel out. So my surface area formula for a triangular prism is BL plus AH plus CH plus BH. But look at this. These 3 terms all have H as a common factor. So I can actually factor this and make the formula even simpler. So I end up with the surface area of the triangular prism is BL plus H multiplied by A plus C plus B, or A plus B plus C. Okay, so you've got the formula for volume and the formula for surface area for a triangular prism that's labeled this way. So if you had actual measurements with values for these, you could just plug those numbers into the formula and you get the surface area or the volume. In this next example, we're going to develop a formula for surface area and volume of a cylinder. So here I have a cylinder pictured. R represents the radius, H is the height of the cylinder. So we'll start with volume. Remember, the formula for the volume of a prism is area of base times the height. Well, this is a prism because there's a circle parallel to another circle and they are joined at right angles to each other. Okay, so we have parallel faces. That's a prism. The base of this prism, well, what are the 2 parallel sides? It's the circles. So the area of the base is the area of the circle, pi r squared, times the height, which is h. So the volume is pi r squared h. Now surface area is a little bit tricky. We know that there's a circle on the top and a circle on the bottom. So each of those are pi r squared. But then what do we do with this side that curves around? The way I like to picture it is, imagine this is a can. So you use your can opener to cut off the top of the can. You use your can opener to cut off the bottom of the can. That's the two circles, the top and bottom. The tube that's left over, take your scissors and cut down the side and then unroll the thing. And the shape you're left with is a rectangle. Okay, so you take that tube, cut it down the side, unroll it, now you have a rectangle. Well, the height of the rectangle we know is h, but what about the length of this rectangle? We need to know what that is in order to find the area of the rectangle. Well, remember, we unrolled the rectangle from when it was a tube, right? And it was wrapped around the circle. So the length of that rectangle is actually the circumference of the circle. And if you'll recall, circumference of a circle is 2 pi r. So the area of the rectangle is, well, length times width, 2 pi r times h. Okay, so if we want to find a formula for the surface area of a cylinder, well, we've got two of these, 2 pi r squared, and we have one of these, 2 pi r h. So we have 2 pi r squared plus 2 pi r h, and I can simplify this by factoring. Notice 2 pi r is a common factor. So surface area is 2 pi r multiplied by r plus h. So there you have a formula for volume of a cylinder and the formula for surface area of a cylinder. So if you know the radius and the height, you just plug in those values into each of these formulas and you get your values for volume and surface area. All right, in the last two examples, I have prisms that you probably haven't worked with before, so they're a little bit different. So let's start with volume. Okay, this is a trapezoidal prism. That means the base of the prism is a trapezoid. So remember, for any prism, the volume is the area of the base multiplied by the height of the prism. Well, the base is a trapezoid, and in the warm-up, we wrote down the formula for the area of a trapezoid. So we just have to plug our numbers into the area of a trapezoid formula multiplied by the height of the prism, which would be 12, and we'll get a volume for this trapezoidal prism. Now the issue is, okay, A and B, well, A is the shorter side, B is the longer side, so the shorter side is 8, so we have 8 plus 10 in brackets. The height, that's this part here. We don't know what it is. So we're actually going to have to do some work to figure that out. Take a look at this. If the shorter side is 8 and the longer side is 10, they're parallel to each other, and these are the same size. That means if I made a right triangle on either end, well, this part, straight down, this would have to be 8, because I make a rectangle here. Because I know the total is 10, that means I have to have 1 on either side, so that my total length is 10. So now I have a right triangle where the one side is 1, the hypotenuse is 4. I can use Pythagorean theorem to find the length of the other side. So 1 squared plus h squared equals 4 squared. Rearrange that. H squared is 4 squared minus 1 squared. Okay, so when I do that, 4 squared is 16, 1 squared is 1, so 16 minus 1 is 15. To find h, I have to take the square root of that. So if I do my work off to the side, this part here, the height of the trapezoid face, is the square root of 15. All right, so now area of the base of my prism is the area of this trapezoid. So it's 8 plus 10 in brackets, multiplied by the square root of 15, all of that divided by 2. I multiply by the height of the prism, which is 12. Now I'm going to clean this up. 8 plus 10 is 18, divided by 2 is 9. So I have 9 times the square root of 15 multiplied by 12. And if I do all that in my calculator, the volume is about 418.3 units cubed. There's no units indicated here, so I just wrote units cubed. All right, now let's try surface area. It's going to be a little bit easier. Remember, surface area is just the total of the area for each surface. Okay, so I've got two trapezoids that are the same. I have a rectangle over here that's 12 by 4, and the same on the other side, 12 by 4. Then I have the top rectangle, 8 by 12, and the bottom rectangle, 10 by 12. So if you add up all those areas, you end up with approximately 381.7 units squared. So even though this is a weird looking prism that you probably haven't dealt with before, because the base face is a trapezoid, you can still use the same principles for volume of a prism, area of base times height, and surface area, just add up the areas of each individual face. This is my last example for a prism. This is a pentagonal prism because the base shape is a pentagon. Okay, so if I know the radius, and by that I mean from the middle of the pentagon perpendicular to one of the sides, that distance, I'm calling that R, and B, I'm calling the length of one side of the pentagon, and I'm assuming they're all the same side length here. This is a regular pentagon. Okay, and then H is the height of the prism. Okay, so volume is area of the base multiplied by the height, but what's the area of the base? This is a pentagon. I don't have a formula for the area of a pentagon. However, you can figure it out. If I take the pentagon and I draw from each corner to the center, I end up with 1, 2, 3, 4, 5 different triangles. Okay, well, I know how to find the area of a triangle. In this case, it'll be B times R divided by 2. And I have 5 of those. They're all the same. So I end up with 5 BR over 2 as the area of the pentagon. So now I can take that and put it in here for the area of the base multiplied by the height. So I end up with a formula for the volume of a pentagonal prism of 5 BRH over 2. And now surface area. Well, it's the total of all the areas of each face. I already know the area of the pentagon, 5BR over 2, and I have 2 of them. And then I have 5 rectangles that are all B by H. So now if I simplify, well, 2 divided by 2, that cancels out, so I'm left with 5BR plus 5BH. Now 5B is also a common factor, so I end up with 5B multiplied by R plus H. So there you have volume and surface area for a pentagonal prism. Now the last thing I want to talk about is volume of a pyramid. So a pyramid can have lots of different shapes. The basic idea is that you have a base shape, and it's different from a prism because the sides don't all go up to a parallel face. Okay, they all meet at a point above the center of the face, the base face. Okay, so in this case, this is a square-based pyramid. We don't call it a circular-based pyramid. This is a cone, but it's the same idea. Okay, so I want to distinguish between H and S here. H is the height of the pyramid or cone, whereas S is called the slant height. It's from the point of the pyramid perpendicular to the base along the outside. That's called the slant height, whereas the height of the pyramid is inside the pyramid from the point down to the center of the base. And it's the same in a cone too. Okay, whatever kind of pyramid you have, whether it be a cone, a square-based pyramid, a triangular-based pyramid, a pentagonal-based pyramid, whatever, the volume of the pyramid is equal to the area of the base times the height of the pyramid divided by 3. So keep that idea in mind as I go through the next example. Here's a pentagonal-based pyramid. We want to develop a formula for surface area and volume for a pentagonal pyramid. Okay, so I've labeled some things. B is the length of each side of the pentagon. This is a regular pentagon. R, I'm saying, is the distance from the center of the base out to the midpoint of one of the sides. H is the height of the pyramid. So from the point to the center of the base, and S is the slant height. We'll start with volume. Since this is a pyramid, volume is area of the base multiplied by the height of the pyramid divided by 3. Now the base is this pentagon. If you'll recall from the previous example, the area of a pentagon we found was 5br over 2. So we'll just plug that in for the area of the base. I'm not going to show how I developed that again. If you forget, you can go back in the video to see how I got 5br over 2. So area of base times the height of the pyramid, which is h, divided by 3. Let's clean this up. So 5brh, okay, divide by 2, divide by 3. So really, we're dividing by 2 times 3, which is 6. So we have 5brh over 6. So volume is 5brh over 6. Let's talk about surface area now. So we have the pentagon, and then we have 5 different triangles. Now I say different triangles, but they're all the same size because they all have B as the base. Now the height of the triangle would be S, the slant height. So we have BS over 2 for 5 triangles. So I have 5br over 2 plus 5bs over 2. And in the numerator, 5b is a common factor, so I'm left with r plus s. And then the denominator is 2. So I end up with surface areas 5b times r plus s, all of that over 2. Okay, so you've had lots of examples here, and the main point is that you would be able to develop formulas for volume and surface area for a variety of different shapes, and then once you have values for the measurements, you can plug those into your formulas and actually solve volume and surface area. So now it's your turn to try the practice questions, and if you run into any trouble, please reach out and I'll do my best to help.